Alright, gang. Section 3.2 definitely relates back to 3.1. 3.1 was about a formula known as the Law of Sines, and 3.2 just kind of continues that story, and it's about another group of formulas called the Law of Cosines. So just like the law of sines, we're using, capital A, capital B, and capital C for the angles, and lowercase a, lowercase b, and lowercase c as the corresponding sides, corresponding as in, again, side A is what would be across from angle A, and side B is what would be across from side B, and so on and so forth. So pause the video if you have to, you probably will, and copy down all of these formulas, let them sink in for a moment, because these are more formulas that we're going to use to solve for missing sides or angles, unknown sides or unknown angles, for triangles that are not right triangles. So these are more formulas we can use if we need, and we're going to do a couple examples where, shocker, we're going to need those formulas because the law of sines will not be good enough. So here we go. Our first of two examples is technically an SAS situation where what we're giving you is a side angle side sequence of measurements, as in angle A is 120 degrees, side B is 7 centimeters, and side C is 8 centimeters. I guess here's the first thing I will point out. I'll go back to the whole that this is a side angle side situation. Ask yourself, from thinking back to geometry class, was side angle side one of those ways, one of those situations that you would be locked into one and only one triangle? The answer is yes. So what that means to us here is that when we work to solve for this triangle, there's only going to be one answer. There's going to be one answer for sure, and it's going to be the only answer possible that we can get. All right, now moving on to actually execution here. If you think for a moment about which law of sines, again, I said the law of sines, which law of sines proportion would get you anywhere? Having big A, little b, and little c. And hopefully the obvious answer is there is no law of sines proportion I could set up that would actually get me anywhere. So it's a good thing we just learned about this other set of formulas, isn't it? The law of cosines. So looking back at your law of cosines, this first version of it, second version of it, third version of it, what could we do? The only option is to find what using the first law of cosines formula, second one, or third one. What can we do with big A, little b, and little c? Well, hopefully you see that with big A, well, there's angle A, big A. We're going to have to use this, right? And which would be still unknown. If we knew angle A, little b, and little c, side B and side C, it looks like the unknown would be little a, side A. That's okay. Having one unknown is actually what we want, because we're just going to solve for that. So we're going to be finding side A. It's our only choice. There's nothing else we could possibly do. So we set up that formula, And, I mean, it's a formula, so what else are we going to do besides substituting in everything that we know? Let's plug in for angle A, let's plug in for side B and side C, and it gets here. So, I mean, now we're really in business of solving for side A, little a. So what do we got to do to solve for A? Well, I mean, we should probably do all of this first. This entire right side can be simplified, and just make sure you're not doing it out of order. You know, the whole please excuse my dear Aunt Sally stuff. But I'm telling you, if you throw all of this into a calculator at once, the calculator should be able to do this all in one go, because the calculator knows what it's doing to a certain extent with order of operations. I mean, as long as you tell it accurately what you want it to do, it'll do it. So it turns out that 7 squared plus 8 squared minus all this multiplied together is 169. So now what do? We still want little a, so wouldn't the natural thing to do here is take the square root of both sides, right? And remember that technically, like in a vacuum, you get plus or minus 13, but think of the context. We're solving for the side of a triangle. It can't be negative 13. So again, you know, but I'm just saying, like, don't ever forget that when you solve equations like this, just isolated on their own without any context to it, just an equation, you would get plus or minus 13, 2 answers. But here, of course, just the positive 13. So, okay, 1 item down and 2 to go, right? Now this is a big moment. Okay, let me just kind of pause and let's all take a mental breath here, because I do want you to understand what happens next. All right. So we found side A. What's left to find are the other 2 angles, angle B and angle C. Let me just kind of, I mean, long story short, and I mean long story short. You might be thinking, hey, I like the law of sines. I like doing the law of sines. I understood the law of sines. Let's just set up a law of sines proportion to figure out angle B and then angle C. Well, you find angle B and then finding angle C will just be super easy, like middle school geometry kind of thing, like we did last unit. But I'm going to tell you this, okay? That could work. That very well will probably work. I mean, I don't know, maybe I shouldn't say it that way, but what I should say is, you know, using the law of sines is an option, but just trust me for now. There is a danger. There is a danger to just, and it would be totally unlucky on your part, but there is a potential danger of being wrong using the law of sines. Okay, so let's just have you do, like, this is my high recommendation, just do the law of cosines again. All right? Instead of going from law of cosines and then doing the law of sines, please just do the law of cosines again to find whatever, to find angle B, right? So next we're going to go after angle B with, of course, the second law of cosines formula, and we're going to plug in for everything we know. All right? And next is kind of a tricky part, because what you do not want to do is all of this math together. All right? You can't ignore the fact that what we have right here is being multiplied to the cosine of b. So here's what you need to do. You square the 13, you square the 8, all right? And then you might even combine those, all right? You could even combine those together. But what you're going to do eventually, with the dot, dot, dot here, is take this sum and subtract it to the other side. And that's where negative 184 comes from. So again, do not combine it with this minus 208. That would be disobeying order of operations, right? Again, don't ignore that we're multiplying the negative 208 with the cosine of b. So what you need to do is add these two numbers together and then subtract it to the other side, and you end up with negative 184. And now, to get cosine of b by itself, now you're going to have to divide by negative 208. And of course, after that, in order to solve for angle b, you do the inverse cosine of that fraction. And I hope you notice that negative divided by negative ends up being positive. And so when you go to your calculator and you do the inverse cosine of that fraction, make sure you put the fraction in parentheses, or you use like a fraction button. Your handy dandy calculator says that it's about 27.796 degrees. Okay? Now let me at this time I'm going to choose to elaborate a little bit more on that long story short. So the reason this is the better thing to do, the ultimately overall safer, less risky thing to do, is when you do an inverse cosine, think about your two options. Yeah, I mean, remember, technically, isn't there two options here? The cosine of an angle could be positive in quadrants 1 or what? What's the other quadrant where cosine could be positive? Isn't it quadrant 4? So yes, technically, big B could be like some quadrant 4 angle, but think about how big the angles are in quadrant 4. You're talking between 270 degrees and 360 degrees. Not for a triangle. So doing this, I guess, in other words, using the law of cosines and doing an inverse cosine is way more reliable here than doing the law of sines and doing an inverse sine, where for an inverse sine you could potentially get two answers that are realistic from quadrant 1 and quadrant 2, right? And like I mentioned back here with the side angle side business, there's only one answer, okay? Doing an inverse sine, you wouldn't know which one to pick, the quadrant 1 answer or the quadrant 2 answer. So, and it could be the quadrant 2 answer for all you know. So that's kind of like a quick mini explanation of, after you do the law of cosines, because you have to, just do the law of cosines again, because choosing between quadrant 1 and quadrant 4 is an easy decision. You go with quadrant 1. And for that matter, if the cosine of b ended up being a negative something, like let's say this was a negative fraction, you're choosing between quadrants 2 or 3. That's where the cosine is negative, in quadrants 2 and 3. That's also an easy decision, because anything in quadrant 3 is automatically too big by itself also, just like quadrant 4. So doing the inverse cosine there's no risk. There's no risk of picking the wrong quadrant. unless you are really being sloppy with your facts. And once you have a second angle along with your first angle of 120 degrees, figuring out the third angle is elementary, my dear Watson. You just figure out what's left over from the 180 degree max. So one more example, one more kind of example, and it's an SSS example, side, 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 which was also something in geometry class that locked you in to like one answer and only one answer. So in this other example where we're going to have to use the law of cosines, there is going to be one solution, and it's the only one possible. Right? So looking at this, I hope it's easy enough for you to realize that there's no hope of doing the law of sines. Right? If the law of sines is possible from the get-go, I say do it. Like, that's what you're probably supposed to do. That is what you're supposed to do. But here we can only do the law of cosines. Now, in this situation, it's like you have a choice, right? You have a choice of which formula you want to use, because I think anything's possible. You could figure out angle A, you could figure out angle B, and you could figure out angle C. You have a choice. Now, some teachers in textbooks might say, hey, you should go after the largest angle. Like, we know that angle B is going to be the largest angle because side B was 10, and that was the longest side, And that way, it's like, if any of the three angles were going to be like quadrant 2 big, and basically, it would be like an obtuse angle, like, remember how any angle more than 90 degrees is obtuse? And so some triangles are obtuse triangles with an angle that's larger than 90 degrees. So if any of these angles had any chance of being obtuse, which again means to me quadrant 2, it would be angle B. And so a lot of textbooks and teachers would have you pick to go after that one first. That way, if there was a quadrant 2 angle going on here, the law of cosines would flush that out beautifully with an inverse cosine. But you actually, since I'm going to recommend you do law of cosines and then another law of cosines, you can actually pick either any angle to go after. You could go after the smallest angle, and it wouldn't matter if what you plan on doing after finding the first angle is finding the second angle, also using the law of cosines. So I think we've already seen this play out in the last example. So we plug in for everything we know, and then again, what you need to be doing here is squaring these two numbers, and then ultimately, and you can combine them to be 89, and then ultimately subtracting it to the other side, or from both sides technically, and then dividing both sides by negative 80. All right? Getting the cosine of B by itself. Because once the cosine of B has been isolated, now you can go in your calculator and do an inverse cosine of that negative fraction, and your calculator tells you 97.903 degrees. So I can't help but notice here that this was a quadrant 2 answer. Huh. Cool. But again, it's like, as long as you're using the law of cosines, there's not really any risk of picking the wrong quadrant and the wrong answer. Because the other possible answer here would be in quadrant 3, as I explained last example, But that's the first angle, and then like I already mentioned a minute ago, even though you could do the law of sines now, I just recommend you do the law of cosines again. And it doesn't matter which angle you pick to go after. I'm going after angle A here, and you plug in what you know, and just make sure that at the end of the day you are dividing both sides by negative 100. You are not mixing all these numbers together. That would be wrong. So you can add these together and then subtract to the other side. But then, of course, you have to divide both sides by negative 100 and get cosine of A isolated that way. And then you're doing the inverse cosine, obviously. These are not new moves. These are the same moves again. So you do the inverse cosine of that fraction to get the answer for A, and it's about 52.410 degrees. And then what do you do to find the third angle? Once you have two of the angles, what do you do to find the third angle? Well, of course, middle school geometry class would have told you to subtract your two angles from 180 to get a leftover of 29.687 degrees for angle C. And again, that's what. So I feel like I should summarize this a little bit. I mean, it's just going to be repeating myself, but let me summarize it this way, okay? If you are able to begin with the law of sines, that's what you do, and you just kind of play that by ear. You know, that plays out the way it plays out. But if what you are forced into doing is the law of cosines at first, I would say just please do the law of cosines again. So do the law of cosines, do the law of cosines again, you know, to get your second answer, and then you don't really need that to do the third answer. Likewise here, we were forced into doing the law of cosines. If you do the law of cosines twice in a row and just resist the urge to do the law of sines, then it doesn't matter, even though you had your choice here, didn't matter which one you would choose to solve for first, as long as what you were doing was the law of cosines again. And that would be that for section 3.2, people.